Hello friends, in this video we will study about the various addressing modes used in the 8086 microprocessor. So let us start with our topic. We know that the microprocessors, they are the programmable device. Means that the user, it can write the programs if it want to use the microprocessor for certain applications. So depending upon the applications, the programs are written. So programs are what? They are a set of instructions, and instructions are the commands given to the microprocessor that it has to perform a particular function. So instructions, we can say that it is the command, or it is an advice given to the microprocessor that it has to perform that particular function. Now instructions, they consist of two parts. One is the operand and second is the opcode. So instruction, it consists of two parts, that is opcode and the second is the operand. So opcode, it is the operation which is to be performed, and operand, it is the data on which the operation has to be performed. Okay, so opcode, we can say that it is the operation to be performed. This operation can be anything, like it can be an arithmetic or logical operation, or it can be any type of operation which we want that the microprocessor should perform. So this is the operation, and operand, it is the data on which the operation is to be performed. So opcodes, for various types of instructions, we have different opcodes. Like for addition, we have ADD. For subtraction, we have SUB. Means we have the mnemonics defined for each of the operations which the microprocessor can perform. Now the thing comes for the operand, that how the data on which the operation has to be performed, that is specified in the instruction. So this is the way in which the operand is specified, that is known as the addressing mode. So if we define addressing mode, then it is the way of locating the data or the operands, or we can say that the different ways So addressing mode, it is the way of locating the data or the operand, that how the data is specified in the instruction, or we can say that the different ways in which the source operand is specified in an instruction. So that is known as the addressing mode, how we are addressing the operands in the instructions. So in this video, we will study the various addressing modes used in the 8086 microprocessor. First, let us see that how the instructions are classified on the basis of the flow of their executions. Based on the flow of execution of instructions, they are classified into two categories. One is the sequential control flow instructions, and second is the control transfer instructions. So these are the two types of instructions on the basis of the flow of execution. When the microprocessor it is executing a program, then if it is executing the instructions one by one, means in a sequence it is executing the instructions, so that is known as the sequential control flow instructions. Means when this instruction is executed, then after that the next instruction which is written just after it, that will be executed. Now, if there are some instructions which transfer the control to some other locations like jump instructions, call instructions, these instructions, what they do, they transfer the execution of the program from one memory location to another memory location. So the control has been transferred. So those instructions are known as the control transfer instructions. The example of sequential control instructions are the arithmetic and logical instructions, and processor control instructions. So these instructions, they do not transfer the control to some other location. The instructions are executed one after the other, means the sequence in which they are written in the program. Whereas in the control transfer instruction, the execution is transferred to some other locations like jump, call, int, return. All these instructions, what they do, the address which is written after these instruction, the microprocessor it is going to jump to that location and then it is going to execute some instructions which are written at that location. So the control is transferred. Now for these two types of instructions, there are different addressing modes. First we will study the addressing modes which are used for the sequential control flow instructions. The first addressing mode for the sequential control flow instruction, it is immediate addressing mode. In the immediate addressing mode, the data which is to be operated, means the operand, that is specified in the instruction itself. So that data, it is known as the immediate data. That data is available in the instruction. So there is no need to search the operand. It is available in instruction itself. So in this addressing mode, the immediate data, it is a part of the instruction itself and it appears in the form of successive bytes. So immediate data, that is operand, it is available in the instruction itself. So this type of addressing mode is known as the immediate addressing mode. An example of this is these two instructions, they are the example of immediate addressing mode. Here this instruction says that you have to move the contents which is written here in the instruction, transfer it or copy it into the A register, that is accumulator register. Now accumulator, it is a 16-bit register. It is denoted as AX. So it can be divided into two parts, that is higher order byte and the lower order byte. So 16 bits are divided into two 8 bits. So here it is written AL, means the lower order accumulator register is used. So here we have the 8-bit data. So this 8-bit data, it is copied into the AL register. So AL will have the FF content. Means the data which is to be moved, that is available in the instruction itself. So it is a type of immediate addressing mode. Next we have move AX0005H. So this data, it is a 16-bit data, and here the complete accumulator register is used. So AH and AL, that is a complete AX register, it will have 00 and 05H. Okay, so this complete 16-bit data will be transferred or copied into the AX register, and the data is specified in the instruction itself. That is why it is known as the immediate addressing mode. Now whenever this immediate data is used here, so the size of the data and the destination where the data has to be copied, it has to be same, because here we are transferring an 8-bit data. The immediate data, it is of 8-bit, so the destination place, that is also of 8-bit, that is lower accumulator register. Here the data, it is of 16-bit, so the destination is also a 16-bit. So the destination and the source, they will be of the same size, okay, either 8-bit or 16-bit. So this is the first type of addressing mode, immediate addressing mode. Second, we have the direct addressing mode. So in the direct addressing mode, the 16-bit memory address, that is directly specified in the instruction. So the 16-bit address, memory address where the data is available, that address is specified in the instruction. Let us take an example. So here the contents of this 4321 memory location, they are transferred to the CL register. So here we have the count register, which is the CX, divided into two, CH and CL. Okay, so CL, there will be an 8-bit data, because CX, it is a 16-bit register. So 8 bits are there. Now this 4321, it is the 16-bit memory address, or we can say it is the effective address of the memory location. Now in 8086, the address, it consists of two parts. It is generated by adding the segment address plus the offset address. Okay, so offset address is provided in the instruction 4321. We have to use here the segment address. So segment address, suppose we are having the data segment register here. So DS, suppose it is initialized at 5000. Now this data segment address, it has to be multiplied with 10H. Okay, so 10H, when it will be multiplied, so it is a 16-bit address, it will become a 20-bit address. Okay, now in this segment address, the offset address will be added. So offset address is given in the instruction, that is 4321. So the complete physical address of that memory location, it becomes 5000 multiplied with 10 plus 4321, so it becomes 5432 and 1H. Okay, so that is the address of the memory location where the data is stored. So here at this memory location, an 8-bit data will be stored, so that 8-bit data will be transferred into the lower count register. Okay, so this here we are not giving the operand, that is the 8-bit data. We are not specifying that data in the instruction. We are giving the address where that data is written. Okay, so this is this type of addressing is known as the direct addressing mode. Okay, so the address of where the data is stored, that address is given in the operand. It is specified as the operand in the instruction. If we take another example of this, we have move AX 5000H. So here the effective address, it is the 5000. So 5000 will be added to the data segment address, and then that address will be transferred into the AX register. Okay, so here the data which is to be transferred, that will be the 16-bit address. Okay, so that is also a type of direct addressing mode. The next type of addressing mode we have is the register addressing mode. So in the register addressing mode, the data on which the operation has to be performed, that is the operand, that operand is stored in the register. Okay, so register itself is the source of the operand, and the data is stored in the register, and it is referred by a particular register. If we take example, so these two instructions, we have the data is stored in the AX and the BX register, and the data in these two register, it will be added, and the resultant will be stored in the accumulator. Here we have addition and move. BX data will be transferred into AX, and here the CX and AX, they will be added. So the data which is to be transferred, that data is stored in the register. That is why this is known as the register addressing mode. Here the register, it is the source of the operand. Next type of addressing mode is the register indirect addressing mode. So in the register indirect addressing mode, the address where the data is stored, that is specified indirectly. Means the register in which the address is stored, that will be specified in the instruction, and the data is stored at that memory location. Okay, so it is specified in an indirect way. The offset address of the data, it is in either the BX or the SI or DI or BP. BX, it is the base register. Then we have the source index, destination index, or the base pointer. So these registers, they can be used to contain the offset address of the data. Let us take an example so that it will be clear to you. So in this instruction, the data which is stored at some memory location, that data has to be moved into the accumulator register. Now this BX register, it contains the offset address of that data. Offset address means suppose it is containing 4895H. So that is the offset address. Now we have to add this address into the segment address. If we are using BX or the source index or destination index, then our default segment will be the data segment. And if we are using the base pointer, then our default segment will be the stack segment. Okay, we can use data segment also and extra data segment also, and here for the base pointer we will use the stack segment. So suppose the data segment, it is initialized at suppose 1000. Okay, so 1000 will be multiplied with 10h, and then this 4895 will be added. So what we will get? We will get plus 4895. So our physical address, that is the address of the memory location, will come out to be 14895H. So the location where the data is stored, that location is given in the register, and that register is denoted in the, that register is specified in the instruction. So the memory location where the data is stored, that is not directly given, it is indirectly given through a register. So it is known as the register indirect addressing mode. In the register addressing mode, we have studied that the data was in the register itself, but here the data is at some memory location, and that memory location is contained in the register. So it is a type of indirect addressing mode. Okay. Next, we have the next addressing mode as the indexed addressing mode. So in the indexed addressing mode, the offset address where the data is stored, so that offset address is stored in one of the index registers. We have two index registers, source index and destination index. Okay, so this offset address will be stored either in SI or DI. So for SI we will use the data segment, and for the destination we will use the extra segment. Okay, so let's take an example here. We have move AX and SI. So here the offset address of the operand, that is the address where the data is stored, that address is given in the source index. So source index, suppose it is having 50H. Okay, so 50 will be added to the accumulator, to the data segment multiplied with 10H plus this SI, okay, the number which is stored in the source index, and that will be equal to the physical address. Means the address of the memory location where the data is stored. Okay, so that data will be moved into the accumulator register. Suppose there 4321H it is stored, so that will be moved into the accumulator register. It is a 16-bit number, so at the memory location, first the 8-bit data will be stored, and incrementing it by 1, the next memory location will be storing the second 8-bit data. Okay, so in this way the data will be moved into the accumulator register. So here the address where the data is stored, that is stored in the one of the index register. That is why it is known as the indexed addressing mode, because we are using the index register, source index and destination index. Next addressing mode is register relative addressing mode. So in the register relative addressing mode, the data is available at an effective address, and that address is obtained by adding an 8-bit or the 16-bit displacement with the content of one of the registers B, X, BP, SI or DI. So we can use any of these registers, either base pointer or the base register or source index and the destination index register. So in this, the data is available at an effective address. So let us take an example so it will be clear to you. So in this, the data which is stored at some memory location. So the address of that memory location, it is formed by some offset address plus the segment address. So here the effective address is formed by adding the 8-bit or the 16-bit displacement. That displacement will be specified in the instruction. So here we have 50H, that is the 8-bit displacement. So that will be added in the this BX register contents, plus this displacement will be added with one of the registers BX. So suppose that this BX, it is having 4321H. So it will be added with this displacement 50H plus the data segment address, that will also be added here. So data segment multiplied with 10H. So this complete forms the address of the memory location where the data is stored. So we are adding here the register is there plus the displacement is also there. So that is why it is known as the register relative addressing mode. Here we are getting the effective address by adding the register plus the displacement and the data segment also. We can use data segment and extra segment. Both these segments can be used depending upon which register is used here. So this is the register relative addressing mode. Next we have based indexed addressing mode. So in this based index addressing mode, the effective address of the data, it is formed by adding the content of the base register, any one of the base register like base register and or the base pointer. They can be used and they are added to the content of an index register, either source index or destination index. So we have both the base register plus the index register. So this addressing mode is known as collectively the based indexed addressing mode. Let us take an example. So in this, the effective address of the memory location where data is stored, that is obtained by, so that segment will be used here. Suppose we are using the data segment, that will be multiplied with 10H plus the contents of this base register, that is BX, plus the contents of the source index, so SI. So this is complete forming the physical address of the memory location where the data is stored. So we are using base register also here, and we are using an index register also. So this type of addressing mode is known as the based index addressing mode. Okay, suppose this is having 4321 and this is having suppose 5678. So this will be added with this plus the data segment address. Suppose it is 1000, so 1000 multiplied with 10. So 10 this is 10,000 plus 10 plus 4321 plus 5678. So that will collectively form the address of the memory location where the data is stored. So that 16-bit data will be transferred into the accumulator. Next, we have the relative based index addressing. So here we have in the relative register addressing, we have seen that we are adding a 8-bit or 16-bit displacement also. So in this also we are going to have an 8-bit or 16-bit displacement plus the base register plus the index register. Okay, so that will collectively form the effective address. So effective address will be equal to the 8-bit or the 16-bit displacement plus the base register and the index register. So if we take an example, we have move AX 50H, BX and SI. So here we are having this 8-bit displacement plus the base register and plus the source index. So physical address will be equal to either of these segments. We can use data segment or the extra segment. That will be multiplied with 10H plus this 50H plus the contents of the BX base register plus the contents of the source index SI. So that will be the address where the data is stored. So if we see that in these addressing modes, we have there are different ways of defining the address of the memory location where the data is stored, that is the operand is stored. Okay, so just the difference is there of defining that effective or the physical address. So these were the addressing modes for the sequential control flow instructions, that is those instructions which do not transfer the control to some other location. They are going to execute the instructions one by one in a sequence. Okay. Next we will study the addressing modes for the control transfer instructions. So control transfer instructions, they are going to transfer the control or the execution to some other memory location. Like we were having jump, call, return and interrupt. So for these instructions, we have different addressing modes, that is inter segment and intra segment. Inter segment on intra segment, the difference is that the memory location where the execution is transferred, whether this memory location it is in the same segment or a different segment. In 8086 we have four types of segments: data segment, stack segment, code segment, and the extra segment. So there are four types of segments. Now if the program it is transferring the execution from one segment to another segment, like from DS to SS or from DS to CS or ES, so that will be known as the inter-segment mode. Okay, means control is transferred to some other segment. And if the control is transferred in the same segment, means the address of the memory location it is in the same segment, so that will be called the intra segment. So there are two types of modes in this. So for these two modes we have the two addressing modes, either direct or indirect. Means directly the address will be specified in the instruction or it will be specified indirectly. In intra segment also we will have direct and indirect. So we have in total we have four addressing modes: direct inter-segment mode, indirect inter-segment, intra-segment direct, or intra-segment indirect. Let us see some examples so that it will be clear to you that what are these addressing modes. So this instruction, it is an example of the inter-segment direct addressing mode. In this, you can see that the execution it is transferred to some other memory location, and that memory location is directly specified in the instruction itself. Now the segment is a different segment, so that will be the 2000 is the effective address and 5000 is the segment address. So here we have effective address 2000 H in segment 5000. So the address it is directly specified in the instruction itself. Next we have the inter-segment indirect. Example of this will be so here the address is not directly specified, it is written indirectly. So data segment will be added. This is the offset address. This will be added in the data segment address, and that address the program or the microprocessor it is going to jump at that memory location. Okay, so directly the address is not specified, the offset address is given. We have to add this offset address in the data segment address, and then we will get the physical address. Okay, here physical address can be obtained by adding 5000 and 2000. So both segment address and offset address both are given in the instruction itself. Next we have intra-segment direct and intra-segment indirect. So intra-segment direct means that the segment is same, segment address will be same, only the offset address will be changed. So offset address will be directly specified in the instruction itself. This short label, it is a notation that where the loop is written, so that loop will be executed, or this label is written, wherever this label is written, the microprocessor has to jump to that location. So directly the memory location is specified in the instruction. The segment is same. Okay, here also segment is same, but the offset address, it is specified indirectly. The offset address is stored in a register. Any of the base register can be used, and that offset address will be added to the segment address, and at that location the microprocessor will jump to execute the other instructions. Okay, so these are the addressing modes for the control transfer instructions, where the execution is transferred to some other memory locations. So in this video, we studied about the various addressing modes which are used in the 8086 microprocessor. So I hope that this topic is now clear to you. Thank you.